Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Under acid, H+, catalysis, alpha, beta-unsaturated carbonyl compounds, enones, can undergo intramolecular Nazarov type or acid-catalyzed electrophilic cyclization reactions. The starting material is cyclohex-1,N,1-Yl, phenyl ketone, where the C is equal to C of the cyclohexene ring is conjugated with the C is equal to O, an enone system. The phenyl group is also conjugated with the carbonyl. Step 1. Identify the reactive system. The substrate has a vinyl ketone, enone, conjugated system. The endocyclic double bond of cyclohexene is alpha, beta to the carbonyl, and the phenyl ring is on the other side of the carbonyl. This sets up a cross-conjugated diene-1-divinyl ketone arrangement analogous to substrates that undergo the Nazarov cyclization. Step 2. Nazarov cyclization pathway. In a Nazarov cyclization, a divinyl ketone undergoes acid-catalyzed 4-pi electrocyclic ring closure. Here, the two vinyl groups are 1. The endocyclic alkene of cyclohexene and 2. The phenyl ring acting as one vinyl component. Protonation of the carbonyl oxygen activates the system toward conrotatory 4-pi electrocyclic closure. The oxylyl cation, pentadienyl cation, undergoes ring closure between the terminal carbons. Step 3. Ring closure. The terminal carbon of the cyclohexenyl double bond attacks the ortho carbon of the phenyl ring, or equivalently, the electrophilic carbon attacks the nucleophilic pi system, forming a new C to C bond and creating a 5-membered ring fused between the cyclohexane and benzene rings. This gives a bicyclic intermediate with a cyclopentenyl cation. Step 4. Loss of proton and rearomatization. Loss of a proton restores aromaticity to the benzene ring and gives the final product, a fused tricyclic ketone. The product is 2,3,4,4A tetrahydro 1H fluorine 9,9A1, commonly called 3,4,4A 9A tetrahydro 1H fluorine 9,2H1, or simply the octahydrofluorinin with the ketone at C9, the ring junction carbonyl. This matches option C, a structure drawn as a cyclohexane ring fused to a cyclopentanone ring fused to a benzene ring, i.e. 1, 2, 3, 4 tetrahydrofluorine 9-1. Step 5. Why other options fail? Option A. Simple isomerization of the double bond position in the ring with retention of the open chain ketone, not favored under these conditions when cyclization is possible. Option B. Reduction to an alcohol requires a hydride source. H+ alone does not reduce the ketone to an alcohol. Option D. Eliminated because option C correctly describes the Nazarov cyclization product. Therefore, the correct answer is C. Therefore, the correct answer is option C.